Hello. Okay, so I'm going to talk about the synchronization algorithm in the desktop client. I'm Olivier. I work for Wobok. I'm a contractor of Enclode, working on the desktop client. So the basic architecture here of the desktop client, csync is a library. At the beginning, there was csync, and it was doing synchronization from a client to a server using all the different protocols, such as SFTP, WebDAV, Samba. And so Enclode took it and decided that it was a good start to do the synchronization client. And then came, well, and Miral was the graphical interface on the top of that, to have some buttons to configure your folder and to synchronize your file. Csync was very abstract. You could use many protocols, but Enclode only needs WebDAV. And because of all those abstraction layers, it was really hard to make good performance and take the maximum and the best synchronization software we can do. So therefore, we have changed csync a bit, and we stripped all the part that we don't need. We broke all the abstraction layer, and we now still use the same concepts that csync used, but we've re-implemented a lot, and now we only support WebDAV, and even WebDAV with Enclode, because there is a few little extension that improves the performance a bit. So csync is the base, the old library, and libenclode sync is the library which we did on top of csync. Miral is the name of the desktop client, and Enclode CMD is a little wrapper around libenclode sync that do not have a GUI. Now I'm going to try to describe a bit the algorithm. There is 3 phases for the syncing. First phase is the update phase. Discovery might be a better name. Reconcile and propagate. I'll explain each of them. So the first phase, the discovery phase, we go over each file in each folders and each file in the local file system, and we compare to a database which contains what was previously synced. So we know that previously we synced this file and it has this modification time, and now it has another modification time. So mtime here means modification time. So if the modification time has changed, we assume we need to synchronize it. If it hasn't changed, then it's fine. We don't need to synchronize it. So at this point, we only look at the database and the local file system. Still, then there's a second phase in the update phase, in which we now look at the removed folder. So we do WebDAV propfind call, and this time we don't compare the mtime, but we compare the e-tag from the server, and we see if there is a difference. And it's basically it's the exact same logic, just instead of being with the mtime, it's with the e-tag. And we know, okay, do we have to do something for this file or not? And so in this case, we compare the remote with the database. But at no point here we look at both sides at the same time. This is for the next phase, the reconcile phase, in which we then look at the result from the previous phase and see, this file needs to be updated on the local and not on the server. So then we decide what to do for each file. Should we download it, upload it? If we see it hasn't been changed on the local file system, but it's not there on the remote, that means that it has been removed on the remote, and then we need to delete it in the local file system, and the opposite. So that's the second phase, the reconcile. And then, yes, if there is a conflict, in the general case, we are going to download the file from the server and rename the file locally as a conflict file. But we try also to resolve the conflict to see maybe the file was modified both the same in both directions, and then there is no conflict in that case. And so the last phase is the propagate phase, in which we actually do the request to the server to propagate the change that we need to do. And so we do up to 3 jobs in parallel, and after each job, we write the state in the database. So if the sync is aborted, we know what we have already done and we don't do it again. For uploads, we split the files into 20 megabytes. And so if the syncing is aborted in the middle, we already know which chunks we sent, so we resume, basically. And for download as well, so we download to a temporary file, and if the sync is aborted in the middle, we use range request to start again from where we left. And I think that's finished.